Hey everyone, my name is Chimaja Agada. I am a student at Leeds Beckett University and I'll be giving you an end-to-end walkthrough of my student portal microservice platform. We'll cover the architecture, technological choices for live demo and so much more. Let's dive in. Here is the high-level architecture that I used for this project. It is a microservice based design, and each of the microservices are independent of each other, but we communicate making use of RESTful APIs. They are loosely coupled, and it is loosely coupled and scalable architecture. Each of these service for the following reasons: the React and Tailwind for fast component driven UI for the student service. For the back end, I made use of Spring Boot, making use of Maven and Gradle respectively for student and finance service to ensure that my dependencies are managed well, and production ready Java framework with built-in DI and testing support. Flask is lightweight for the library API and a rapid development in Python. I made use of Docker to ensure consistent environment and easy orchestration, and MySQL because it's a reliable relational storage for all storage services, so it's easy to manage and get things done. These are industry standards tools that ensure maintainability, scalability, and team productivity. So how does this all work? So on the screen right now, you can see a UML class diagram to show how each of the core entities interact with each other. We have the student, user, course, enrollment, which are all part of the student microservice. Then in the library microservice, we have the two main things, the library account and books. Then in the finance microservice, we have the finance account and invoice. As you can see, there's a relationship between each of the microservices in such a way that you'll be able to understand how the whole application works. So a user is an actor, is a human actor in the system that is able to interact with the student portal, which is the front end of the application. They are able to move around and just look at other things and look at the books, the courses available. They are able to enroll in a course and they're able to update their profile. For a user to become a student, they have to enroll in a course. When they enroll in a course, they get registered as a student, and upon getting registered as a student, it also enables them to create it automatically creates an account for them in this library and their finance service, making it such that they can interact with those services. So then the system actors, which are the finance API, which is finance microservice, and the library microservice, exposes the endpoints that are greatly used in the general working, which are the registration API, the borrow API, return API, get invoices API. This exposes them, and modeling both human and system actors ensure clear end-to-end workflows. So now I'll be showing how my application works as a new user and show the happy path, which the is the ideal scenario in this process. Here we have the register page, which is the first page you enter when you get to when you enter the application. We're just going to add some dummy details. New user, email address, full name, last name. Now we're going to add a simple password that is easy to remember just for this demonstration. Okay. Password. It's a new simple password. And register. This sends us to the login page, which has already automatically added our details because we saved them. So now let's sign in. Signing in. So now this is the dashboard. This is our main page, home page. So now this is the view courses page that just shows all the courses we already have in the database. This is where we can access the library service, and this part is currently showing error due to it not us not having enrolled a course. Now we're here at the invoice page, which is showing nothing because once again we've not enrolled in a course, and this is the profile that has the base. We don't have any student ID. So now let's try enrolling in a course. Let's enroll for project management. Okay, successful. Let's go. Now we can see in our courses, my courses page, it has been added to our courses, been added to the database. And when we go to invoices, we can see that an invoice has been created for that particular course, and we can see that the student ID has now been generated, and we can now add make changes to the student profile and include our surname and first name. Saving the changes. Good. So now going back to the borrow book, explore the library first service, but first we need a student ID. So I go in here and copy it. From there we now go back to the borrow page, and we can see the default pin. Click on the button and we're redirected to the library portal. We put in our default pin. After putting in our default pin, we are now prompted to add a new pin so that it's something unique to us. I'll put something really simple in, just something for this demonstration. Okay, so we're back to the login page, and now we can put in our new pin, and we're in the library portal. We can see these are the list of books that we have here. So let's borrow one of the books. This is the count. So let's try borrowing one of the books now. So we'll borrow the first one. Put in the ISBN number. Unfortunately, there's no more copies of that book in the database, so we cannot borrow it. Let's try another one. Okay, put in it. Let's go. We've borrowed the book. So now we have the date return, and it now shows up in our account. And now let's try returning the book. So when we return the book, it ensures that we do not if it's overdue by date to show. So let's go back and try and pay for our invoice. Right here, click pay now, and voila, we've paid for our invoice. Back to the profile, let's check our eligibility. It works. So this is working because we don't have any invoice remaining. So let's try enrolling for another course, the software engineering for service computers. Great. We have the invoice. So let's check our eligibility again. Oh no, it's not working. We have an outstanding invoice. So now let's go and check it out. Click pay now. We've paid for it. So now let's try checking our eligibility again. Check eligibility. Good. So this is how the whole system works. So now let's talk a little bit more about the microservice and other alternatives to this service. We apply true microservices, independent code bases, data stores, containers, and REST interfaces. It gives us independent scaling, fault isolation, and text flexibility, which is ideal for growing platforms. But there are other alternatives to creating a project like this. And let's look at the pros and cons. If you use a monolith architecture, it's simple to set up, which is great if you're trying to just make something easy. If you're just trying to make something that is simple and one base, but it doesn't make it easy for you to scale it for a to a larger project. And when you want to deploy it in a ma at in a and you want to deploy it in a large scale, it is hard and it's not suitable for that. Another under monolith, we now have modular monolith. Yes, it has clear code boundaries. However, it's still the same thing, has the same problems with normal monolith. It's a singular process and it's coarse scaling. It has easy local testing. However, because it's same problem with monolith, it's a single you can only do single deploys, and you can't scale the modules independently. And lastly, we can also do serverless slash FAAS, which is a way in another alternative to using microservices. It auto scales, it's pay per use, and like the advantage is that it's auto scales and it's pay per use, so it's not difficult per se. It's much, you can scale it more than the monolith. However, it has code start delays and distributed debugging, so it's harder for it to debug your code. So let me introduce something that I used in this project: dependency management and dependency injection. Dependency management is the process of identifying, tracking, and controlling the dependencies between different components of a software system. In this case, in the student service, I made use of Maven, which by using the pom.xml file can use to manage the dependencies. This is an example of it in my code. Just a short example that shows there are still more dependencies. Then in the finance service, I use Gradle, and then in the Flask, I made use of requirements.txt file. Each of this, it helps analyze and minimize disruptions caused by dependencies to ensure smooth project execution. I use different dependency management software. I use different dependency management tools to get more experience into how each of them works and the pros and cons. Dependency injection is now a design pattern, a way we design our code to achieve loose coupling between classes and dependencies, so that the code becomes easy to maintain, enables dynamic configuration, and allows such that one code doesn't have major impact on the other side of the code, ensuring that each side, to some extent, yes, they're dependent on each other, but at the same time they're not dependent on each other. So what I'm showing you now is the student controller the student controller for the project. In here, I made use of a constructor injection. I made use of constructor injection, which is a type of dependency injection that explicitly passes, that is, the dependencies are explicitly passed as parameters in the client's class constructor during object creation. So here we can see that the student service, integration service, and user service are all explicitly passed as parameters in the client's class in the student controller's constructor. This makes it sure that they are the the required dependencies are clearly defined, and ensures that these dependencies are enforced at object creation, which prevents runtime errors, which could happen due to missing dependencies. So now I'm going to talk about the service integration approach I used in my project. In my student microservice, I implemented a synchronous point-to-point REST integration using an orchestration pattern. This means that the student service directly communicates with the finance and library service using HTTP requests, and it waits synchronously for their responses before continuing. The, the integration is orchestrated and not event driven, meaning that the student service coordinates the workflow, not an external system. For example, in the code you see on the screen, when a student registers, when a student registers, it first calls the library account and sends a request with the student's details. Then it also sends a request with this to the finance service with the student's details, all in a predefined sequence. This approach ensures tight control over the flow and simplifies debugging. An alternative to this approach is asynchronous messaging, which coupled with a choreography pattern ensures that services react to events like registered students independently. For this project, I focused exclusively on unit testing using JUnit 5 and Mockito. Unit testing lets me validate individual classes in isolation. No need to start up databases or HTTP servers. The example on screen is a test for the user service impli.java file. We're testing simply creating a new user and ensuring that it works appropriately. So this unit test uses Mockito to mock the user repository, so no actual database is involved, and the test verifies that the service returns a non-null user with the expected ID, and the repository save method is actually called exactly once with the correct input. With this setup, my core business logic is covered by fast, reliable tests that catch regressions immediately. So that's it. That's my student portal platform. 3 Dockerized microservice linked by REST, each with its own each with its own tech stack, clean dependency and dependency injection, and thorough testing. Some of the limitations in this project include no retries or circuit breakers. I could have added Rafka for more reliance, the service integration was more event driven rather than a sequence. Added better security for the authentication aspect, and implemented centralized login metrics and tracing. So that's it. Thank you for watching.